So at the moment our ball is just very simply bouncing off our paddles. In the classic kind of Pong style, if we were to hit the ball while we're moving down, our ball will kind of go down faster, and if we're hitting it up, it'll go up faster. But at the moment that's not happening with us at all, and at the same time our ball is just staying at constant speed as it bounces off our paddles. It's not really getting any faster. We want to make it a bit more interesting and make our ball speed up as it bounces off our paddles. So let's make some changes to our code which will allow us to do that. So if we go into our paddle controller script, what we're going to do is add a new variable that's going to be used to determine if our paddle is moving up or down. So what we're going to do is create a new public float that we're going to call direction. And basically what we're going to say is if our paddle is moving up, we're saying the direction will be 1 because we're going up. If our paddle is moving down, we're going to say our direction is -1 because it's going down. And if our paddle isn't moving at all, we're going to say the direction is 0 because we're not going anywhere. So we're going to use that simple 3-number system to control how our ball is bouncing off our object and how it's being affected by the paddle as we play our game. So if we're going to apply our directions, so when we're moving up, like I said, we want our direction to be 1. So we can say here direction equals 1. When we're moving down, we want our direction to be -1. Direction equals -1, like that. And then we want our direction to be 0 when no buttons are being pressed. But how can we tell if neither of those 2 buttons are being pressed? Well, basically we can reorganize this, our little if statements here, to allow us to make a third if statement, or basically not a third if statement, but a third condition basically. So what we can say is after we're checking for the input of W, so if our W key is being pressed, then we're checking for if our S key is being pressed. So what we can do is combine those and say if W key is pressed, do that little bit of code, else, we say else like that means we're going to do something else, and we're going to say, if we delete all the space in between, what we're saying is if our W key is being pressed, do that, or else if our S key is being pressed, do all that. And then finally we can say else like this, and we don't have to add another if statement. What we can do is just add some curly brackets, and basically what this means is if the W key isn't being pressed and if the S key isn't being pressed, then neither of those is being pressed, so we know that our direction now should be equal to 0 because we're not pressing either direction, so we're not moving at all. So how can we apply this to our ball to actually affect it and make it have make some changes to it as it's going along basically? So what we can do is use a thing down here, just so after our update loop, so after the closing bracket of our update, we're going to add a new thing down here which is called void on collision exit 2D, and then inside some brackets here we write collision 2D other. So on collision exit 2D is another function built into Unity by default, similar to how we have our start function and our update function here. On collision exit 2D is basically something that gets called whenever an object stops hitting against another object. So we have our ball bouncing against the wall here. So when it hits against the wall first, there's a thing called on collision enter 2D, which very simply means that two collider objects have hit against each other. Then there is on collision stay 2D, which means that two objects are still touching each other and in the current update loop, for example. And then finally we have on collision exit 2D, which means on the current frame, two objects that were touching have stopped touching each other. And basically we can use that to say, okay, our ball is no longer touching our paddle. Now the only two times that we'll have to worry about this is if our is if the paddle is touching us the ball, because our paddles won't be interacting with anything else really. At the moment, our paddles are able to go up and off the screen, so they're overlapping with the walls, but we're not actually going to allow that in the final game. We're going to make some changes a little bit later. So we know that we're only really going to need to think about what's happening with the ball. So within the bracket here, we have collision to the other, and that's basically saying this is the thing that will be interacting with us. So we can refer to whatever is the other collider that is hitting against us. So what we can do is say the other object, the rigid body that is attached to that, we're going to adjust the velocity of it. So in our case, that'll be the ball. So what we're saying is the other object that hit against us, we're accessing the rigid body that's attached to it, because we know our ball has a rigid body. We're accessing the velocity of that ball, because we know we set that velocity at the very start when it started moving. So what we can then do is say the velocity of the ball should be equal to a new vector 2, because again, it's a 2D rigid body, so it only has the x and the y values. We want to make no changes to the x-axis for the moment, because we want it to keep moving at the speed it's going. We're going to change that in a minute, but for the moment we'll just stick with it as it is. So the other.rigidbody.velocity.x, so the current x value, we're applying that right back into it. But on the y-axis, what we want to do is get the other.rigidbody.velocity.x, and what we're going to do is add on the direction. So what we're basically saying is if our direction, if we're moving our paddle up, we have the direction set as 1, and so if our ball stops hitting our paddle, we're applying this direction to it. So basically if we're moving up and down, it'll change the direction that the ball is heading in slightly. So I'm going to close that bracket, and I'm going to hit semicolon here, and we're going to save this and go back into the game. Let that compile down the bottom here, and once it's finished compiling, we can hit play now. And what we should see when our ball is moving up and down, so well, I missed it, so that's not very helpful for anybody. If we could maybe play the game with a bit of skill, we'd be okay too. But we should see if we move down. Oh well, I'm not particularly skilled at these games. I can make the games, I can't play them very well, is the main problem I have. But you can see if I could manage to hit them face on. But we saw there the ball actually moved quite weirdly. It moved completely opposite of the way I expected it to. So it moved fine when I moved down there, but if I move up, it also moved fine. Just want to make sure there's not something strange going on here. Oh, of course. I set it to be the velocity.x. It should be the velocity.y, because we're accessing the y-axis. It makes no sense to be applying the x-axis to the y-axis. Sorry, that was a slight error there. So we go back in, let that compile again, and we'll hit play. And hopefully this time I should be able to hit the ball with the paddles. And we should see that we can affect the direction that the ball is traveling. So if I can manage to, there we go, we move down. It does affect how the ball is bouncing. You can see it's now bouncing at a much shallower angle, so we're getting more bounces as it goes, but there's not very much. So let's add another variable that we can use to control how much adjustment we're applying to our ball. So what we're going to do is we're going to go into our script. We're going to add a new variable that we're going to call public float adjust speed, like that. And then down here we're going to multiply our direction by the adjustment speed. So we're going to say direction multiplied by adjust speed, like that. So we're going to save that, go back in here, let that compile, and then Oh, I just realized if I hit play here, it's not going to do a lot first because we need to go to our paddle and we need to actually give these a value. So our just speed, we're going to set this to be 2. Our direction doesn't actually need a value. That should actually probably be a private value, not a public value, but that's okay for the moment. I'm going to apply this to our other paddle so it works just the same. And then we're going to hit play here. And now when the ball moves up and bounces, we should hopefully, there we go, we can see much more visually now that the ball is bouncing higher and at a shallower angle. So if I keep doing that, if I can manage to kind of do the opposite, you can see now that our ball is actually moving at a much sharper angle. So it's taking less bounces as it goes. So you can see we're actually making some changes to how the ball is moving around in the world at the moment. But the only thing now is that our ball is still traveling at the same speed as it goes backwards and forward. So let's make a little bit of an adjustment to that in our paddle controller script here. So what we'll do is basically make it so that at the moment we're setting it so that the x velocity is always constant, but let's adjust that so that every time we bounce against the paddle, we're going to multiply that by 1.1 f. So every time our ball starts bouncing, we're going to speed up a tiny little bit. So if we go back in here now, again we'll let that compile, and if we hit play, because we're setting it to get that tiny bit faster as we go, it's not going to be overly kind of visible to us. You will feel it getting faster as the game goes on, but it's kind of it's a little bit of an increase. It's not super obvious as we play. So we know that when we're making a game, you always want to be able to track and make sure that things are actually happening. You don't want to be just leaving these things up to feel and not being sure about them. So what we'll do is, just after all of this here, so we're going to go to the end of that line and move down, we're going to do a thing here called debug.log. And what debug.log does, we can put within these brackets here, we can send a message out that will go to the console here. And what it'll do is we can tell it to, we can basically say, okay, here's a variable that I want you to display on screen. So if we go here and say debug.log, we want to display the other.rigidbody.velocity. So we want to know what is the current velocity of the other object when it leaves the paddle. So if we save that and now go back in here, it'll appear in the console here, but it'll also appear in the little kind of status bar down the very bottom. So we don't actually have to have console open while we do this. We can go back to our project view, and if we hit the play button, let our game get started. As soon as we bounce off a paddle, we should get a message which didn't appear for some reason. Oh no, we should have got a message. I'm not really sure what happened there. I just realized what the error was there. It's not because it's not being sent to our console, it's because this little information kind of button hasn't been pressed. So you can see the last couple of messages from when I just ran the game a second ago are still here, but it's because they weren't pressed by default. I'm not really sure why. It's a strange thing that they wouldn't be defaultly pressed within Unity, but that's okay. So now if I hit play again, we should be able to see them in action. So if there we go, we get the numbers down at the very bottom there. We get the other rigid body's 2 values, so we can see the x value is slowly getting bigger, although it's going between minus and positive, of course. But we can see there that the x value is getting larger and larger as it goes, so it's getting faster and faster, and our ball is moving faster and faster as it goes. And that's exactly what we want to happen. We want our ball speeding up, and now it's making the game a little bit more interesting. So now that our ball is moving the way we want it to, let's add some more gameplay into the game and make it so that when we get to the either side, we can actually do some stuff as we go.